My name is Kevin Funk. I'm working for the company KDAB. If you don't know KDAB yet, KDAB is a group of leading expert providers of Qt, C++, and OpenGL consulting, development, and training service. We've been around since 1991, and we've been basically doing Qt projects for over 20 years now, and we have helped a lot of customers in that range. You may know us from all the past Qt conferences we did, where we are known for delivering high-profile technical talks. We're around 90 people right now, located all around the world. Just a few words about me. So my current title is Senior Software Engineer, but I'm basically juggling between different roles at KDAB. I'm doing sales, engineering, that means talking to customers early for things like trainings, mentorings, development service and things like that. But I'm also still doing software development for customer projects and things like that. I'm a consultant and trainer at KDAB since 2009. And I'm a Qt developer since 2006. And I've been regularly contributing to things like the KDE and Qt ecosystem and free software in general. So you might have seen me on the Qt mailing list or Qt code review system for things like CMake support in Qt and things like that. Right. And these days I'm mainly interested in tooling because I quite like to manage large code bases, like code bases of an IDE, for instance, where I can do mass scale refactoring of source code using Clang-based tooling. You might have seen my other talk at past Qt conferences. And this kind of goes hand in hand with the build system in place, because Clang-based tooling, it actually needs to know what kind of compile flags, what kind of compile definitions include paths I need to be able to parse a certain source file. So the build system in place, it also needs to be able to extract this kind of information to the users. And CMake is a pretty good candidate in that regard because it has pretty tight integration with things like Clang-based tooling. It allows to extract this information I just talked about pretty easily by just asking it to do it. Right, so I'm doing this kind of trainings and workshop in KDAB right now, things like CMake trainings, Git trainings, workshops around Clang-based tooling. So yeah, that's kind of the thing I'm after right now. So what is CMake? First of all, I'm just going to give a little bit introduction to that, and we'll just dive into a little bit of CMake code right away. So basically, I grabbed this information from Wikipedia. So Wikipedia says CMake is a tool to simplify the build process for development projects across different platforms. CMake automatically generates build systems such as Makefiles, Ninja, and Visual Studio files. So what's the interesting thing about this? CMake, in fact, got the de facto standard for C++. De facto standard build system for C++ projects lately. That has been noticeable for all kinds of customers projects we got lately. They basically, most of them, they all use CMake. There's quite a high cross-platform aspect attached to CMake. It runs from pretty little embedded boards to all kinds of different desktop platforms, and it's easy to bootstrap. That's one of the major advantages. So if your platform doesn't support CMake out of the box, doesn't have pre-built binaries built for it, you can easily just run a script and you can have a working CMake thing afterwards. Right, and one major thing about CMake is that it's not driving the build itself. CMake is a meta build system, so it will instead generate build systems. So as we said, it will generate build systems for the make file build system, for Ninja, and also it can create Visual Studio project files or Xcode project files. This allows CMake to run on any platform and use the most favorite build tool on that specific platform. And also the IDE integrations, they allow for really good integration in the IDEs. You can open any kind of CMake project in Visual Studio and have all the nice IDE integration in there, like the file explorer, like listing targets and so on and so on. So what is this thing we call modern CMake? Also just diving into that very quickly. In a nutshell, forget about all the commands you've learned or used in the past, like add, compile, options, include directories, link directories, and link libraries. Instead, embrace using the modern variants. They all start with a target prefix, and they operate on an individual target, while the other ones, they basically just change the state of the currently passed CMake folder, like where the CMake list.txt file is located. So the first ones will actually change a lot more state compared to the other variants. Another thing, prefer functions over macros. Macros have the problem that if you set variables inside macros, they will escape the scope, and the variables will show up in the calling scope of that macro. That's not intended and would change state too much. Also, keep internal properties private. So do not propagate things like -w error to users of the library. So you might want to build your specific library with that warning enabled, but you do not want that users have to use that library when linking against the library. So it's all about keeping state clean in modern CMake world. And also about modules, create and use exported targets. So you might have seen the way CMake worked in the Qt 4 times. You actually had to use things like this variable called Qt library in order to link against it. That basically just resampled the path to the actual library on disk. So it didn't contain any information about like how it was compiled, what compile flags used for this library are, and so on and so on. But in the modern world, you'll have specific targets for that. They are called like Qt 5 : GUI. And that is really a kind of an object which not only says where the library is located on disk, it also tells you what kind of compile flags you need in order to link against it. Like in the Qt 5 world, Qt 5 core will actually demand that any user linking against Qt 5 core will need C++11 support nowadays. So there's kind of a transitive propagation of property going on, that any kind of user of Qt 5 core will need C++11. So it's kind of some magic going on there. Next thing, what are the advantages of that? As I said, the requirements are attached to the targets, not propagated through the whole build system. So there's a lot less, less things propagated through the build system. And also things like selecting modern C++ standards is quite simple using modern CMake stuff. For instance, you can just ask a target to use a CXX standard 11 property, which basically means that any target using my target, so if you look at target compile features, my target public CXX standard 11, that means any target linking to my target will need to have C++11 support enabled as well. Or you can set that globally by just setting the CMake CSX standard to 11 and also set it to required later on. That's kind of pretty nice because CMake allows to ask the compilers in a cross-platform way that C++11 support is needed to compile this project, and you don't need to worry about like doing compiler checks and things like that. CMake has that built in, and CMake does it for you. All right, so getting started. What does modern CMake in the Qt world look like? This is basically the example you get from the Qt 5 documentation. And this is how the most simplistic CMake project using Qt looks like. So again, there's like some boilerplate code. You start with CMake minimum required, which is pretty normal. Then you write down the name of the project. But then already comes the interesting part, which is special to Qt. So in fact, in order to embrace using modern CMake, we try to enable things like AutoMock, AutoRCC, and AutoUIC. I'm going to explain how that is being used later on. But basically, it enables Qt magic behavior, CMake magic that enables Qt-specific behavior for mock, QRC, and UI files. And then we also ask it to include the current directory automatically. That means as soon as you build a certain target, CMake will ensure that the current source directory and current build directory are already part of the include path. That's needed because CMake will generate the mock files and things like that in the build directory. In order to use these mock files inside your source files by including them, for instance, you need to have this include path available. And CMake pretty much makes it very easy to not have to worry about include paths by just setting this variable. Then the next interesting thing is, how do we actually find Qt 5? And In CMake, there's a find package function you can use for that to find any kind of packages. And in that case, we ask it to find Qt5 and the component widgets. And we also mark it as required. That means CMake will bail out if it doesn't find Qt5 widget component. Next thing, we're adding our target, our executable, which is called hello world in that case. And we ask it to build the sources mainwindow.ui, .cpp, main.cpp, and resources.qrc. And as we've learned before, due to the fact we enabled stuff like AutoMock, AutoRCC, and AutoURC, CMake knows that for .ui files, it needs to run the URC compiler in order to generate CPP code. And the same goes for CPP files. CMake scans all the CPP files attached to targets, tries to find the accompanying header, and checks whether the header contains classes that contain the QObject or QGadget macro. And as soon as if a source file does that, CMake will create rules that ask mock to be run on that header file as soon as the build is started. So there's a kind of clever magic going on. You don't actually need to list the header files in executable. CMake will figure it out on its own. And it will also run mock on these header files, even if they're not listed here. So this is quite convenient. And same for QRC files. CMake knows that it needs to run RCC on these files to be able to generate CPP code. And after doing all this investigation, CMake will also add the generated files to this hello world target. So if you, in the end, try to build that hello world target using your favorite build tool, CMake will compile all the CPP files and all the generated files generated files it created. Right. So there's nothing to worry about running mock or doing anything specifically here. In the end, we also need to link against the library we found. So we need to write target link libraries, our target, and then Qt5, and then the component we try to link against. And that's it. That's basically all you need to do in order to get working Qt application built with CMake. All right. Right, running out a command line is pretty easy. I think I don't need to go into details here. It's basically similar to the CMake world. You just create a build directory, then you run CMake on the source directory, and you can also pass additional asks to it in order to instruct the build, to enable specific options, to set a specific compiler or add compile flags and so on. And then you can actually build that project using CMake-build dot. Dot refers to the current build directory. And in fact, CMake will just invoke the build system tool required to build this project. So if we started CMake and asked CMake to generate a build system for make files, it will just run make under the hood. If we asked it to generate Ninja build files, it would run Ninja under the hood. And this is basically just a convenient way to build a project if you don't care about the build system under the hood. And this is also useful for running CMake in a CI if there are multiple build systems in use and you just don't care about the build tool in use. So that's about that. Right, and a common issue we experience with the Qt integration in CMake is that people are not able to find the correct Qt install using the command line in CMake. And actually there's just one single thing you need to remember. You need to remember the CMake prefix path variable. And in order to let CMake find a specific Qt install, you can either pass the CMake prefix path variable as a command line argument to CMake, or you can export it as an environment variable beforehand. You can export it, you can set it like on Windows, and you need to let it point to the installed prefix of Qt. So this is the directory, at least on Linux, where lib, bin, and these kind of folders are in. And this is all the magic you need. You don't need to set path additionally or something like that. CMake prefix path is the only thing you need to remember. And that's also quite nicely explained on the CMake manual on the Qt documentation page right now. There's been quite a few changes lately to make this more prominent. Right. Right, and CMake prefix file is basically just a generic way to make find package in CMake look at different locations for additional packages. It's just a very generic way to do this. It's not specific to Qt. So this is a good thing to remember general about CMake. Right, next one. You might want to troubleshoot why or which kind of Qt version you have found. CMake doesn't print that on the command line when you use this kind of setup I just described, but you can easily just go to the build directory and then go to that file called CMake-cache. CMake-cache is basically a key value store of things CMake tries to remember for the next CMake run, like where it found libraries, what kind of options were enabled, what kind of compiler we are using, what kind of build system we're using. That's all stored in there. And if we want to figure out what kind of Qt we found, just grep for Qt5 in that file, and you'll see we ended up with these locations. So Qt5 core was found in blah, 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 Qt5 core, Qt GUI was found in that directory. And of course, on Windows, this looks completely different, but in the end, this gives you an idea where this kind of things were found. Right. Obviously, if there's no Qt install found at all during the CMake run, CMake will complain and will bail out pretty early. Right. Just as a short idea about how this looks in Qt Creator. Basically, the CMake integration in Qt Creator got better quite a bit lately because the developers working on the IDE have been spending quite a bit of time there. And pretty much all you need to do to open CMake projects right now is to open the top level CMake list file via File, Open File or Project. Then you select the CMake list file, and then Qt Creator will ask you what kind of Qt kit to use in order to build it. And then you can basically work with the project as usual. That means you can run, you can ask Qt Creator to build the project, you can ask Qt Creator to run individual targets, and you can also ask Qt Creator to switch between different build types like release with debug info, debug, or release builds. And the nice thing about Qt Creator is that it has basically all the kit handling built in. You don't need to worry about CMake prefix path and setting up the environment to run your application. That's all done within Qt Creator. It will handle the multiple Qt versions you might have with ease. So there's nothing to worry about. And yeah, if you're not a command line fan, I really recommend just doing it via Qt Creator because it saves a lot of trouble. Right. Just a few more words about the CMake Qt integration. With that new AutoMock, AutoRC, and AutoURC, there's actually no need for these old-fashioned functions anymore called Qt rep CPP, Qt rep UI, Qt add resources. These were used for basically creating these rules for running mock, for running RCC manually by specifying on which source file RCC and mock need to be run. But that's no longer needed. You can just use AutoMock and then just list the source files in the targets. And basically, you don't need to worry about this anymore. This simplifies CMake code quite a bit. And interestingly, that also leads to faster overall builds. We just had that in a customer project where we basically were able to save a couple of minutes of build time by just using AutoMock instead of the old way of using Qt rep CPP. In that customer project, I'm talking about the build times were like, I don't know, 20 minutes in normal times. And with AutoMock, we basically were able to shave off 1 minute of build time because it made it a lot faster. And the reason for that is with the traditional Qt rep functions, CMake actually created rules that in the end ask the compiler to compile each generated mock file individually. And that's kind of a problem because each compiler invocation is kind of overhead. It needs to scan include paths, it needs to pass the source code, and so on. So there's a lot of overhead related to that. And especially on Windows, this is quite noticeable. And CMake AutoMock has kind of a performance improvement feature there. So instead of just invoking the compiler for each generated mock file, it will first generate a so-called mocks compilation file, which in turn includes all the generated mock files. So if you have 10 sources, which all need mock to be run on them, there will be just one mocks compilation file listing or including all the generated mock files individually. And in the end, there's only one compiler run being invoked on this CPP file. So it's basically 10 versus 1 compiler invocations, and that's quite a bit of an improvement in that regard. This is quite a nice feature. There are similar ways to do it in CMake, but the way it does it there is a little bit different. It basically, in CMake, you can ask it to compile the mock generated file as part of the real source file, so it's a little bit different there, but that also saves compiler invocations. So that's quite interesting, and it's super easy to port to AutoMock in the end. Some special casing regarding AutoMock. If you have QObject or QGadget in a header, then there's nothing else to be done. CMake will run mock on the header if AutoMock is in place. But if one of these is in the source file, you actually need to do a little bit of extra work. You need to include basename mock at the end of the source file. So CMake will know it will also need to run mock on the source file, not on the header. So that's just something to keep in mind. And actually, let's go back again. This is also pretty nicely documented on the CMake AutoMock page. If you Google for CMake AutoMock, there's a huge man page which will discuss these kind of things. And also CMake will look for other Qt macros requiring mock, for instance, Q plugin metadata. Right, and this list can actually be extended by the user. For instance, KDE has a lot more macros, and they also need to run mock for them. And in KDE, they have a really huge list of macros which will trigger the run of mock in the end. Right. More special cases. Another source of problems is usually translation handling. I'm just going through this pretty quickly. In order to enable translations, first of all, there's business as usual. We do the CMake minimum required, we do project, we set up AutoMock, etc. But in order to get access to the functions for creating translations, we also need to find package linguist tools. That's a package which defines additional CMake functions. And in order to let CMake run things like L-update and L-release, we can use this function called Qt5 create translations. You'll pass it an out variable, which means CMake will store the list of generated files in there. And you will also pass it the source directory where L-update will go through and check whether it needs to extract translations. And then you also define to which kind of files it's going to extract translations into. And the nice thing about this here is that CMake will take care of either creating these translation files called TS files, or it will take care of updating them if they already exist and maybe even already exist translations. So it will not overwrite existing translated translation files. Right. And in order to make sure this is also built as part of the normal build, you'll need to attach the variable QM files we just created over there to the target of interest. I'll just check, right. That's basically about it. And if you start to build a project, you'll notice that CMake does its magic, and it will run L-update on the source directory. It will say it updates one of these TS files. And in the end, it will also take care of running L-release and run and generate the QM files, which are basically the binary representations of those translation files, which can later be loaded into the application using qtranslator load. So in the end, you end up with QM files. You can either deploy them to a resource and then load them using qtranslator load, or you can also just place them in the build directory and load them there, or you can also install them via CMake install routes. There are a couple of examples about that on the the documentation page as well. But yeah, that's basically the magic for this. Another thing we just want to quickly talk about, big resources handling. This has been a recurrent problem as well. So you might want to embed large files into resources, QRC files. An example for this is database files. I've heard, or I've seen customer projects putting several 100 MB large databases files into QRCs. And actually, by default, the way QRCs are being handled, it will not work out of the box, because RCC will create CBP files containing basically a character array of the binary data of these embedded files, and it will then try to compile this, and usually the compiler will just fail with an out-of-memory error in that case. And there are basically numerous bug reports about this, because the embedded files, they got larger and larger and larger, and people fall into this trap. And actually, there's a fix in Qt 5.12 for this. There's a new function called Qt 5 add big resources. And this is basically the counterpart to CMake's config plus equals resources big. That's just doing a trick internally. It's not trying to compile the binary data as character array. It's basically doing a little trick. It will just generate a binary stream of data into a separate file, and then in the end embed that into a kind of skeleton resource CPP file, and then link that together. So this is basically working around the fact of working around the issue with failing compilers for that use case. Right. General recommendations. This is about modern CMake usage again. This is just a few recommendations we have seen, or we would recommend to people using CMake. Do not overuse global variables or global commands. Like, as I said in the start, don't use things like add compile definitions, include directories, and so on. Also, do not just override variables like CMake CSX flags, which is the variable to control the global compiler, global C++ flags amended to the compiler. And you definitely want to amend them instead, because people would like to, or potentially would like to, override or extend the compiler flags via the CMake command line. And if you just override that variable inside your build system, people don't get the expected result. We've seen that problem quite a few times in customer projects. Right. Embrace using targets and properties. So don't use global variables. Instead, attach properties to targets, like compile flags, compile definitions, include paths, and so on and so on. And make sure they propagate where needed. So in case you want include paths to propagate to users of your library, use the public keyword when setting properties on a target. And if you don't want to do it, you use the private keyword. Right. All of this, in fact, helps to avoid repetitive CMake code. What else do we have? Right. Do not overuse file clop. That's another big thing we've seen. People usually would like to keep the CMake build system as simple as possible, and usually they try to go with this approach, like just saying, well, all files ending with .cpp, let's compile them as part of my executable target. But in the end, that doesn't work out well, because in order to let CMake pick up new CPP files, it would need to rerun to be aware of these new files which are being added. And this is not helpful. In fact, you should try to just list all the individual CPP files individually and make sure to add them all to add executable or add library calls. Right. And just one last thing before I end this. In order to improve the CMake runtime performance, it's really recommended to switch to the Ninja generator, because it's basically a much more simple build system. In the end, if you run CMake and generate Ninja build files, it will end up just generating one single file, and the Ninja build system will easily just build your project a lot more faster. Look at that link for more information about that. Let's check what else do I have here. Right, and last but not least, treat CMake like production code. This is a very important point. Don't just dump things into the CMake code. Really treat it like a normal C++ code base, and keep it clean and refactor when needed. That's quite important. Right, some resources. There's a well-written intro to modern CMake hosted here. We, KDAB, created a Qt and CMake white paper. It's brand new, actually. You can find it here. And also look at the Qt 5 CMake manual if you want to learn more. This has seen quite some improvements lately, also due to the fact that CMake and Qt 6 will in itself switch to the CMake build system for building Qt. So there have been quite some improvements. Right, and a little bit of things about KDAB. So that's where we are operating. We're doing all kinds of services around Qt. We provide workshops in the areas of profiling, tooling. We also provide trainings in these areas. If you're interested, just drop me a line and we can help you to get started. And that's basically it. If you want to learn more about us, follow us at kdab.com or on Twitter on kdabqt, or on YouTube. We just have a brand new channel you might be interested in. Have a look at that. If you want to drop me a line, just send me a mail to kevin.funk@kdab.com. Right.
Great. Thank you, Kevin. I think we have some questions, quite a lot of questions actually to go through.
Yeah, quite a few. Let me check what I... yeah, let me just check the first one. So there's a question about when I have a number of libraries to build and I use target commands for each of them, don't I repeat myself very often? That's a true thing. But usually you end up just having, some kind of core library, like the Qt 5 core library, where you can basically set all the properties you're interested in for the whole project. And using the right amount of public keywords, you can actually make this propagate through the whole project. So you have one single core library where you set things like, well, I need C++11 for that. I need this compile flags to be available and things like that. And basically through the CMake magic, this will propagate to the whole build. So that's one approach to do that. But in the end, you are right. If you don't link against a core library all the time, there might still be the use case that you use the traditional commands, which are a little bit discouraged, but they are still there, right? Right. The next question is, what is modern CMake, from which version? Another good question. This started quite a while ago. It's not brand new or anything. Modern CMake started with CMake version 2.8, which is a couple of years old already. We are right now at CMake 3. I don't know, 16, 17, something like this. I suggest to just have a look at these intro to modern CMake talks. There's one from Daniel Pfeiffer, which is really, really good. It's a 1 hour long, I think it's a CPPCon talk about modern CMake. This is really recommendable. Oh yeah, next one is also good. Will there be some kind of QMake to CMake conversion tool when CMake will become the standard choice? First of all, QMake will still be around in Qt 6 time. It's not going away. But in the end, at some point, you probably would like to switch to CMake. That's right. I know, because I've been involved with this, that for turning the CMake-based build system of Qt into CMake, there have been written quite a few conversion scripts which automatically pass CMake and then generate CMake code. In fact, this is right now quite limited to the Qt code base. They have some specific demands there, but I don't see the reason this cannot be made more useful for the wider audience. So anyone using or having a CMake build system could make use of these conversion tools and generate CMake code. I think there will definitely be some efforts in that regard. Maybe even from our side, from KDAB. Yeah. Well, I'll skip that one. In which creator version this modern CMake is available? Well, it's basically independent from that. You can install any kind of CMake version side by side. It's not coupled to CMake, to Qt Creator. Qt Creator doesn't even ship with CMake. You need to install it yourself. Oh, that's a good one. Will the header files magically appear in generated Visual Studio or Xcode projects if we don't mention them at execute? That's a very, very good point, because by default, it doesn't do that, but there's actually some functionality built into CMake, which makes it relatively easy to add this. You should have a look at the command called target_sources. It basically allows you to create set of source files to be displayed in IDEs. So you can basically define a set of header files, you can define a set of source files, you can define a set of UI files, and they will be nicely separated from each other in the IDE in the end. I just did that for a customer for a Visual Studio project. Maybe I can share code if you drop me a line. Right. Yeah, about it, someone is asking, why wouldn't CMake auto XXX also add or set CMake include current year? That's actually a pretty good question, because in the Qt 5 CMake tutorial, I think it's optional since CMake 3.7 or something. You don't need to set CMake include current year anymore. I think it's inherent from that. If you set these flags, it will also set the other CMake option. Is there a reason why Qt Creator creates CMake-based projects by default? Well, just not changed right now yet, right? CMake is still the currently used build system, and I think also for, yeah, they do not want to switch that before Qt 6 times. That's my thinking. What else? Oh, wow, lots of questions.
I think we have time for a couple more questions.
Yep.
And then for the rest, we'll get back to the people who have asked the question separately after the session.
Yep, I'll answer a couple more live. So what about CMake for iOS? That's another interesting point. CMake has gained better iOS support just lately. I think a couple years ago, there was basically non-existent upstream iOS support in CMake. This was only, or being able to build for iOS was only possible by using external CMake scripts. There was a GitHub project which was specifically dedicated for that. But I think as part of the efforts to get Qt itself to build on iOS, there have been quite some efforts in CMake upstream to make this to improve iOS support in CMake proper. And this was even driven by some of the Qt company employees. I think the guys like Alexandru, who've been the main driver of the CMake port, they have added pretty good iOS support in CMake by now. You might want to have a look at the recent developments in CMake for that kind of question. Right. How hard is it to port an older project to this new approach? Does the content from this presentation work on older Qt versions? Yeah, basically anything I presented, it will also work on Qt 5.9. It's basically around since the very early Qt 5 X days. So I don't see why it wouldn't happen. I shouldn't work with those kind of versions.
We have time for one more,
Yep.
One more quick one, yeah.
Oh, maybe this won't end up with a short answer, but what is a proven benefit of CMake over QMake for Qt file projects? So this is, of course, a pretty subjective one, but I'm not sure. CMake has the benefit that it has quite a large community around it, and especially for things like finding third-party dependencies easily on different platforms. There's tons and tons of find modules and find scripts available, which you can just use from the internet to be able to find, for instance, exotic third-party libraries. And that's just not available for QMake. Same goes for building more complex projects. If you've ever built a multi-lib or multi-plugin project with QMake, you may have run into the issue of not being able to propagate properties of libraries to other targets. It's relatively difficult to do that with QMake. One primary example of that is the Qt Creator code base. If you look at that, you'll see that there are a lot of files called like library.pri or plugin.pri, and they contain lots and lots of boilerplate code to be able to propagate a state of a library or properties of a library to other targets. It's relatively difficult to get this going. What I usually end up when doing something like this is really going to the Qt Creator code base and copy these .pri files and just make it work in my new project or in my customer project. And with CMake, this basically just works out of the box because you have this automatic propagation of properties. When you use this target compile features or target set properties with the public keyword. So that's something where CMake really shines. Yeah, but I think that's it. If someone wants to have something else answered, just drop me a line. Definitely, there are like 55 questions by now, or at least open things. I cannot answer them in any time frame.
Great. Thank you so much, Kevin, and thanks everyone for joining and for your questions. Please note that you can find a link to send us feedback or join the live session via qt.io/thankyou-survey. You can also give us feedback at the end of each survey by completing the pop-up survey. We look forward to your feedback, either positive or negative. You can join the next live session via the live event page, and you can also chat to our professional services on the live chat on the event portal. But thank you again, Kevin, for your insightful presentation. Like mentioned, the questions that weren't covered in this live session will be followed up with. And thank you again for joining. Thank you. Bye.